All right, here we're going to have to do two things. We're first going to identify the particle for each formula, like which representative particle we're going to be counting, and also convert the number of those particles into moles. Okay, so the first thing I'm going to do is, I left a blank here, I didn't do that in the PowerPoint, okay, but this way we can figure out what is that particle. Okay, so you got to figure out, okay, is this an element or a compound, and if it's a compound, is it ionic or covalent? All right, so CO2, I know that that has to be a compound. Two reasons. I see two capital letters. That's signaling that I've got two elements there. But I also have a subscript. And there's not any single element that has a subscript when it's by itself. Okay, so it's definitely a compound. And I know it's covalent because I see carbon and oxygen. So I've got those two nonmetals. It has to be covalent. Okay, and the representative particle for a covalent compound is the molecule. So this problem basically is saying that I'm starting with 4.75 times 10 to the 24th molecules of CO2. Okay. So we'll just go ahead and continue with this. So we're going to take the representative particles to moles. Right? So we're going to start with the 3.75 times 10 to the 24th molecules of CO2. Okay. I need molecules to cancel out, and I want to end up in moles, meaning I want mole on top and Avogadro's number of molecules of CO2 on the bottom. That way our molecules of CO2 cancel, and we're left with moles of CO2. Alright, so here I'm going to divide by Avogadro's number. Okay. So I'm going to take 3.75, oops, I should use parentheses, 3.75 times 10 to the 24 molecules of CO2. I'll divide that by Avogadro's number. We get 6.23, okay, 6.23 moles of CO2. Okay, so if I have that many molecules of carbon dioxide, I've got that many moles of carbon dioxide present. It's a much easier number to deal with. All right, here let's figure out what representative particle we need for zinc 2 chloride. So we see definitely it has to be a compound because I've got two elements. We've got zinc and chlorine, and because zinc is a metal and chlorine is a nonmetal, this is an ionic compound. And so the representative particle is the formula unit. So we've got 3.58 times 10 to the 23rd formula units of zinc chloride. So I need to get to moles, so I'm going to take my 3.58 times 10 to the 23rd formula units of zinc chloride. We're going to get out of formula units and into moles by putting 1 mole of zinc chloride on top. And Avogadro's number of formula units on the bottom. So our formula units of zinc chloride cancel, and we will be left with just moles of zinc chloride. Okay, so I'm going to take my number of particles and divide it by Avogadro's number. So 3.58 times 10 to the 23rd divided by Avogadro's number. I get 0.59. So 0.59 molecules, or excuse me, moles of zinc chloride. Okay, another way I could write this is, so I could say or 5.9 times 10 to the negative 1. Either way. Oops, there you go.